Thanks, Reed. Thanks, Sanjay. And again, we're very excited to be participating in the Network Field Day today. And I want to take 5 minutes to offer some perspective on why the company was effectively founded and what the observations was that we did in the field and sort of like how we came to the point where we are today. And the first observation is we looked at the network as these are typically deployed today. And you see that enterprise WAN networks are centered around two core networks. On the one hand side, there are like private MPLS networks. You carry your business grade applications. They're very expensive, very high quality. But as a result of that they're being expensive, we're going to take very little bandwidth, the minimum amount of bandwidth that we can actually get away with. On the other end of the spectrum, we have the internet links. So they've been historically coming online as more like not necessarily a necessity, but it's something that nice to have. But over time, they started serving as a backup mechanism to the MPLS as well, so that you can fail over your critical apps to the IPsec VPN that runs over the internet. Now, if that failover happens, you of course change the network characteristics quite a bit, and that is obviously something of an impact to the business. At the same time, we see trends towards moving more applications out of the data center and actually into SaaS applications, into the cloud. So that internet link now becomes really critical because you don't want your sales force to go out on a routine basis. That internet link now needs to be highly reliable, and the path towards these SaaS applications that you add into the mix needs to be highly reliable as well. And as a result of these low capacity links, a whole ecosystem of technologies emerged, like WAN optimization controllers, to squeeze the last bit of that very expensive MPLS. So all of these technologies make that network relatively complex, but also very rigid on how you steer applications. So if we sort of like take a clean slate and we think about how we want to do networking, like what are the attributes that we want to see emerge in the networking side? So a couple of them that very often arise to the top of the list is like we want to be able to install branches in a zero-touch fashion. So it's more and more common these days that a CIO basically says, I need to have a branch up and running in 2 days, and you just make that happen. So shipping equipment there in 2 days is already challenging. Getting links to that site is almost impossible. Broadband links usually take a week. DIA links takes about 3 to 4 weeks. MPLS links routinely take 6 to 8 weeks to get installed. So very complicated. So we want to get mechanisms in place that we can with a very low intervention from the IT department, basically roll out new sites, make them fully enrolled in all the policies that we want to enforce. Another item is that we want to utilize that inexpensive bandwidth. So those broadband circuits seem to be very flexible. They come online relatively quickly. There's very broad accessibility of those services down the line at the moment. But we see this at home, like if we get a 100 meg circuit at a home site, that costs us maybe like $80. If we want to get that same DIA level quality at an enterprise site, we're looking at $1,500 to get that same level of bandwidth. Of course, there's differences in quality, but we want to have more of that inexpensive bandwidth rather than that very expensive bandwidth. We also want to be transport agnostic, and that goes over a couple of different items. So we want to be able to include both wired as well as wireless bandwidth. We want to include both public links as well as private links into the mix. And the entire network should also be completely application aware, so that applications take the route not necessarily that is just available, but we want to take the route that best meets the requirement of the application. So if there are applications that are very network sensitive, then we want to steer them towards the better paths on the network. And then two components that we see on the services side. So we want to have both service mobility or application mobility as well as service chaining capability, so that we can move applications around in the network where they're best suited to execute. So why can't we really do this today? And the net result is like you can actually do this today, and we're a couple of allusions to this already, but it comes with a great deal of pain to actually make that happen. So if we look at the networking side of the house, if you look at standardized routing protocols today, they're not really application aware, nor are they link quality aware, right? So there's incursions into that space, applications or protocols like PFR doing sort of like the first forays in that area, but there's a lot more that we want to have out of these protocols. So if we want to if we want to take applications and we want to move those applications over a variety of links, it also becomes very complicated to get those in a high availability scenario. We want to move certain applications to other links in the event that the primary link is failing. So yes, you can do this with PFR today, but if you want to make that now redundant, then it becomes a very complicated event. And of course, we all notice that business or broadband links aren't really business grade at this point, so there are routine outages on these broadband links. And of course, there are large areas of congestion on those links as well, especially if you're on shared media links. If everybody comes home from school, we see dramatic drops in the bandwidth effectively. So on the services side, if we want to extend some of these applications into the branch very easily, we can of course do that with hypervisors, but these are not necessarily low touch devices. So it's somewhat complicated to do that at this point. If we look at the routers and the switches, they come with very monolithic feature sets, so it's very hard to build custom applications on top of it. But I think you're visiting a couple of companies that are trying to change that as well. And then service chaining is up to this point focused almost uniquely on the data center side. So there's very little service chaining events that actually go out all the way to the branch or even into SaaS applications. And then of course we have very limited visibility in where all these applications are going into the network. So it's very hard to get sort of like a single topological view of where my applications are on the network. So we looked at this and we were thinking of like where can we borrow principles from to actually start building a solution on top of this. And the first bucket is the SD-WAN or SD-WAN bucket, where we primarily look at the segregation of control and data plane. And that segregation is effectively there to independently scale both of these planes. And there are vastly different requirements on each of these planes. So on the control plane, there's a lot of state embedded into there. We want to contain that into a couple of locations worldwide, and we want to have that a lot of redundancy built into that. The data plane is something that we want to sprinkle around all over the world as much as possible close to the users, and we want to make sure that it's highly redundant as well, so that users effectively adjust to changing data planes forwarding nodes. So on the cloud networking side, we try to be transport independent so that we can include a variety of networking styles. We also want to include some of that application awareness so that we can move applications to the better path over the cloud. And we want to be able to accommodate multiple topology at the same time. And these topologies they're both applicable to the branch. So we want to have flexibility of like how do we insert that into the branch, especially if there's existing equipment and existing network infrastructure there. But we also want to have the ability to steer applications in a different logical topology across the WAN as well. And then, of course, no cloud application is complete with having a solid multi-tenant infrastructure in there so that we can run multiple customers on that infrastructure and completely segregate those customers as well.
When you talk about multi-tenancy,
right,
that more or less applies just to the controller, right?
No, it actually is both. So the controller is, of course, multi-tenant. There's a lot of states, so we want to segregate that. But our data plane is also multi-tenant. So like the gateways that I'll talk about a little further, so there is a strict segregation on that front as well. And down the line, like if there are customers that are saying we need dedicated gateways in our cloud, that's, of course, another item that we would be able to supply.
Okay, I'll wait.
Sure. Last bucket that we're extracting some principles for is the NFV bucket. We want to make sure that network function virtualization is something that now covers the entire network rather than, again, being just available in the data center. So core principle of NFV is that you can horizontally scale these services, so that is also something that you will see throughout the entire product. So at this point, Steve is going to walk you through a little bit of how the product is set up, and then we're going to start jumping into an actual demonstration of the product.
Great. Thanks, Tim, for the context. Let me give an overview of our solution. No surprise, it delivers on all the design principles that Tim just mentioned. And then we'll dive into the deep dive on our solution next. So the three key components of our solution are the edges, which deploy in the branches, a distributed network of gateways in the cloud. These are multi-tenant gateways. And also the VeloCloud orchestrator, which is our control plane, as well as monitoring configuration in the cloud. So the first component is the edges, designed for zero touch deployment in the branches. It can actually be FedEx to a branch. A non-IT person can just plug it into power. We'll demonstrate the edges. It's connected to any one or multiple circuits. So we'll call home to the orchestrator to get software updates, get policy, as well as get the path selection from the orchestrator control plane. And given that, it will connect to multiple gateways throughout the cloud, so depending on the different destinations. So what we show is if they're going to a SaaS application in the cloud, going to a cloud data center, it will connect directly over the internet to that cloud destination. But with the multi-path optimization, even going through the internet using the closest cloud gateway. In the middle, we can connect also to an enterprise data center, so enterprise app, without installing a device in the enterprise data center. All right, so for the corporate traffic, in addition to the multi-path optimization, all corporate traffic will also be encrypted. So also IPsec, AES 256, IKE, so standard IPsec from all the branches to the gateways, interoperable IPsec to the existing VPN router in the enterprise data center. Or if you're going to a private cloud data center, also a VPN tunnel to the private cloud as well. We also show if you're going direct branch to branch, right? We have a distributed network of gateways, so you don't go through a central gateway. We will select, or again, based on our orchestration, the most optimal gateway to go between the branches, but you still have a service insertion point in the cloud. Sanjay mentioned on both the branches, the gateways, we have different points so we can have the virtual services.
So you're not going direct branch to branch in that case. You are actually going through
So we have
gateway point in the cloud?
So actually we have both options. I'm now showing the use of gateways. In the next build, I'll show also going direct without using a gateway.
Okay, so what would gateway add in the previous picture? Why would you use a gateway, and when would you use a gateway?
So one of the things the gateway adds is if you want to put services in the cloud, in the gateway, so you can actually go, even though we can do an encrypted VPN tunnel end-to-end through the branch, we can add our multi-path optimization service in the gateway. As Sanjay mentioned, our SP partners could also layer on additional services in that cloud POP.
So if you want to have service insertion in the forwarding path, you go through the gateway. If you just need the forwarding path, you go edge to edge.
Correct, and again, we also have service insertion at the branch location as well.
Okay.
So we have the mix of that.
Is there any sort of scaling limit around the number of branches that you can support?
No, so the gateways are stateless, so it's all horizontally scalable. They're all multi-tenant.
Okay. How many branches could I have connected successfully? Like, what have you tested scaling up to?
So it's designed to be 10 to the 6 in terms of branches. For the on-premise devices, for the on-premise devices, then they're scaling per hardware appliance.
Right.
And that's in the 2,000 branch range.
The number of branches scale, that requirement initially came from service providers. So, there aren't too many enterprises that have 10 raised to 6, but service providers do.
Yeah. So
when you say that the gateways are horizontally scalable, how do you use Anycast or something like that to get to any gateway, or how do you do that scale out?
So the scale out is effectively done through the orchestrator. So the orchestrator has full intelligence of all the gateways on the network.
Okay.
The orchestrator will determine like which edge comes online, what their closest gateways is for specific functions, and then.
So you deploy a pool of gateways, and the orchestrator knows where they are, and it goes like edge 1, gateway 3.
Exactly.
Thank you.
correct. So in the previous slide, I showed the use of just internet. Obviously, we also support hybrid WAN branches, meaning internet plus private connections into the branch. So we do that today. In our next upcoming release, we will actually include the private lines fully into the dynamic multipath. So basically saying, and the way we do that is, actually you see on the table here, what we call our data center edge. So with our data center edge deployed on premise in the enterprise data center, then we have the dual-ended service on both sides, so we can do our continuous path metrics, as well as our optimization on both ends, and that's how we get the private line fully into the dynamic multipath. With that also, in this case, we're showing previous model using the gateways. In this case, in addition to all the branches connecting to the data center, We can also establish dynamic branch-to-branch tunnels, so both for the multipath optimization as well as for the VPN directly from branch to branch. And then in this case, there would be no cloud gateway between the branches. So we have that flexibility.
The gateway there with the enterprise data center on the right-hand side, is that gateway in the public cloud or in the private cloud?
It's public clouds.
So these are gateways hosted by.
That one, yeah.
So these are hosted by us in the public cloud. It could be a combination of burst capacity or fixed locations.
So I can't have my own on-prem gateways.
So actually, if you can hold that thought for one more slide, we'll show the variation for the large enterprise and service providers. So ultimately, the benefit of this then is the full build, internet private circuits, direct access, whether I'm going to cloud data center or SaaS application, different gateways, access to an enterprise data center without having to put an appliance on premise, and also access to enterprise data centers where you want the private network to be a full part of the Automatica multipath bundle with the on-premise device as well.
But that means that you take over the firewalling for the customer.
And so in the demonstration, we do have our own app firewall in the edge as well as the data center edge. But as a virtual service, you can turn it off and you can use your existing firewall. So you have that option.
You have the option.
So you can, I can just drop like 3/4 of your solution and just use the edge devices for the transport, and then I use my own firewall to get to the internet.
Correct. Right.
Okay.
In fact, we'll do a deep dive later in terms of this could be the only device in the branch. We can coexist with an existing router, so we really understood.
Okay.
Very important to have incremental deployment if you have an existing router, existing private circuit, existing firewall, very flexible on the deployments.
What's the scalability of the controller, or what's the, I guess, scalability and resiliency on that? We talked about the edge and the gateways, and then we have the single thing controlling everything. So how does that scale? How does that protect itself against failure? And
Yeah, so the controller is also something that horizontally scales at the moment. So we can add that and basically like even segregate controllers. So if you go into a service provider environment, we can have multiple controllers on a worldwide basis as well. But there's actually very little traffic going to these controls. So there's a very light amount of traffic that goes there.
Can I have the controllers on-prem, or do they have to be in the cloud?
Both options are available.
Both options. So actually, good segue into this slide. So Sanjay mentioned the innovative business model as well. Right, so we can deliver the service, basically WAN as a service, to give you the flexibility along with the cloud network. But basically, you can get an all-inclusive subscription. So it's just annual price based on a branch on the tier of capacity through the whole network. So the upper left, so you get the edge, the hardware is included. You're actually not buying it. You get full use of our multi-tenant cloud network, plus the orchestrator in the cloud. Right, so, and then you can connect to SaaS, cloud data centers, enterprise data centers, without putting any appliances in the data center or head end. This is very nice so companies can just deploy a single branch, very cost effective. As you deploy, for example, more devices, large enterprises may want to put their own device in the data center. They may or may not want to use the full cloud capability as we showed before. They can buy component subscriptions, which includes the edge hardware plus the manager in the cloud, and then they can buy the cloud services a la carte.
Okay, so I just want to make sure I got this straight. You've got these edge devices that can talk to other edge devices, and that's IPsec tunnels between them. You got these edge devices that talk to gateways, and that's IPsec between them?
Correct.
And then you've got the orchestrator, which is a cloud-hosted solution.
Cloud-hosted management and controller, correct.
And I'm assuming that there's encrypted communication between all these edge devices.
Correct.
So okay.
Between the edge device and the controller.
And is there only one option for the edge? Is it only physical hardware, or do you have a software model.
If you can hold that for one more slide, and I'll. So the answer is yes. So again, very flexible deployment. So now if we move to it's also available fully as a product. So if the companies are more interested in the traditional model, large enterprise can actually buy the edge appliances. We'll show that as a CapEx purchase for the branch and the data center. The orchestrator can still be a service, or they can take that and buy that as a subscription and run it on premise. The other key thing that Sanjay mentioned is it's also very unique for our solution, architected from the front to sell to service providers. They would still buy the edges as CapEx, but now they would actually buy the licenses for the gateway virtual appliances and the VCO virtual appliance, so they can build and operate their own cloud service for their customers. And so we have the enterprise service option, product option, and then an option for the service providers. And the question that was just asked before, so this is our portfolio I've been talking about the edges. And so they are, and we show we'll demonstrate the branch edge and also the data center edge. Right, so these are appliances. So they enhance the zero-touch deployment at the branch. Right, and they also have the multi-WAN connectivity, so the right set of ports. I think Tim will demonstrate the variety of ports that we have on it. Because it's built on an x86 platform, it's easy for us to offer a virtual appliance version as well. The core to our lineup is what we call the Edge 500 series, which is a variety of these boxes. They support service tiers from 50 meg all the way up to 400 meg. We also have the large capacity Edge initial version, 1 gig. We'll scale up from there. That could be used for the data center as well as for a large branch. And one future product we'll have, currently we do support the 50 meg service through this 500 series. We'll come out with a smaller form factor for that lower capacity service as well.
So, and those middle range ones where you've got the different service tiers, so it's like the golden screwdriver upgrade sort of thing, is it? The box does, the box can do 500 megs, let's say, but you're paying a license 100. I want some more.
All right.
So I say, here's my card, and you go, cool, bang, okay, you now do 200.
Correct, because again, it's really the service capacity. They're connected to the cloud network as well as the orchestrator. So the hardware can support that, but what subscription are you paying for?
Yeah,
it's a very, very easy upgrades between levels.
Do an up and down kind of thing as well. I'm sort of thinking, like I might say, well, shuffling people around, some of that. I know that for the next 3 months, this particular office is going to be doing a whole lot more. I want to change my model a bit, but then later that's just going to become a little branch office, so scale back down if I want to. Do that
right,
kind
so
of
in other words, is the shift from like 100 to 400 a license change, or is it different hardware?
So in some of them, it's basically it's a subscription, it's a service change. And so basically,
golden screwdriver, John.
Yeah.
You know what I mean?
Wrong with that.
It's what you call golden screwdriver.
Right.
It's not a bad thing, but it's useful to know whether you're locked into a piece of hardware, and now it's a forklift replacement, versus a subscription change.
One important thing, and you may want to point this out as well, is that we're not actually selling the hardware. So the hardware is as a part of the service. So if there are upgrades, that there is no change in any capex that you need to burn.
So if I was at the 400 meg and then I said, I really need to do a bit more, and you're like, well, that's cool, we'll just ship you out a 1 gig box.
Right.
Obviously, with
so we may have to, so if you upgrade the service from 400 meg to 1 gig, we may have to ship you a different box, but you're not buying the box, and so it's part of the service.
How are your international logistics with that? I guess maybe that's an offside conversation, but tough, yeah. International has always been a pain point. Okay.
Especially Latin America.
Yeah.
What if you're actually dealing with private clouds that are entirely hosted through third-party infrastructure where you don't have the availability to put hardware in? Is there a virtual version of the product?
So for the cloud, we have virtual appliances
For private cloud?
So you're asking about VPCs, basically, right? Yeah. So we'll get to that as well. But like we basically tie in VPCs with just standard-based tunnels, so we can do built redundant tunnels. In most of the time, like at the point when you get to the gateway, you're already in the data center environment. Getting to the private cloud is usually not a problem on that last mile of the link. So we built IPsec tunnels openly over internet or over peering connections.
Okay, so you're not actually hosting the edge there.
No.
Okay.
We could, but we don't.
So
You don't have to. You don't.
So on the pricing models, since the international may be a bit of a problem, is there a differentiator in cost between your location, I assume?
Our pricing model differs by location.
And you would handle all the international shipping logistics of getting those devices to those sites?
Yes, we're gearing up to do that. Yep.
Okay, gearing up.
Have our cloud delivered. Sorry, I was eating the chocolate. Apologize.
Cloud delivery.
Our cloud actually is international today, so we are already shipping edges out there. We have not covered Latin America as from a customer base standpoint. We started off with North America. We have some footprint in Western Europe, and we've just signed on partners for Japan and China. So now our plan is we don't want to build huge VeloCloud facilities at each one of these locations. So going with a partner, and partner for us is someone who's a channel player and a hosting provider. Because if somebody already has a cloud footprint in that region, then there can be both a channel for us, and they can also host the gateways. So that's kind of the scale-out model from a geography standpoint.
This is a significant reason why I asked about the virtual edge option.
Yeah. So some customers do like that, the virtual edge option. Initially, we build those devices. I mean, it's basically, there's no custom silicon in them because we couldn't find anything that had the multiplicity of WAN interfaces that we wanted, especially in an offering where you could have a virtualization capable processor on that box.
Mm-hmm. Now I see that you list only 2 WAN interfaces on those appliances. So does that mean I can't plug 5 different broadbands into them, or?
Can I take that? So the SFPs are also for the broadband.
The SFPs are also for the broadband. Plus, we can by just tweaking it, make any of the LAN interfaces.
Okay,
they're all multi-purpose.
So the LAN interfaces could be changed over to a WAN role. They're not fundamentally different.
Correct.
Okay. And the USB, like, so would you
USB
support like an
ports as
LTE
Yes.
USB dongle or something like that?
Yep.
That's right.
Very cool.
Can I put 2 edge appliances on one site if I need more than 400 meg, for example?
So you would. So we do have HA, but you would upgrade the appliances, or actually the service, right? So 100 meg, upgrade the service to 200 meg, upgrade the service to 400 meg.
So you have HA model where I can deploy multiple appliances.
In fact, we'll show some detailed topology for that later.
Another question about the international problem. So V6, V4 compatibility, this comes from Matt Oswald, by the way, I'll give him a shout out. What's your V6 and V4 compatibility today?
V4 today.
You went.
V6.
Because some of our sites were finding more and more V6. Okay.
Especially in APAC.
Yeah.
Especially APAC, especially Japan.
Yeah.
So V6
So you
is
don't
where-
have V6 on transport side.
V4.
Yeah. Okay.
So I had a quick question. So given that these are centrally managed and that there are, potentially sensitive data traversing them, can you talk about the hardening of the appliances and how you deal with any of the sensitive data that may transit them?
So, Craig, you want to take the transport?
Yes, please talk into that if you don't have one on you.
Want to answer that?
You could stand up as well.
I might. So the boxes are hardened. Like if you're worried about like sensitive data that flows over the network, so we are working towards getting completely PCI compliant as well and certified on that perspective. And coming back to what Steve was mentioning earlier, you can actually choose how your path's going over the network. So by definition, or by default, we're setting up our VPN through the gateways, and of course there's a decryption cycle because we need insight. But if that is a problem, and banks are typically very sensitive to that, then we can move traffic directly from one edge to another edge where you do full end-to-end encryption.
Okay.
There are also options for like doing end-to-end encryption through the gateway where we don't decrypt, but then we lose some visibility in the gateways.
Okay. So that was a key point. Even though we're showing gateway in the cloud, with a branch edge to edge, it's still fully encrypted end to end.
Related to some of the international questions, so can you sort of containerize or partition what gateways, what portions of the gateway service certain sites can use? So if you run into, like I think some of the EU countries have various regulations around data moving in or out through their borders, like can you control that to ensure that data is not moving somewhere that it's not allowed to by regulation?
From the orchestrator and the business policies, you get to, it's in the previous slide, you get to provision which gateways do you want to handle your traffic. So the multi-tenancy can absolutely be provisioned for different gateways and also for the different VCO usage as well.
Folks, one last question. So we will be touching on a lot of these topics for the next hour or so. So in the interest of time, if we can move forward, and we will be taking the questions as we go along, especially with the demo. So we can take one last question.
Are you going to discuss any virtual edge specs?
In the
ability specs.
In the later session today, we'll talk a little bit about the virtual appliances. Right, we can do it in the branch. We have our native services. We have the cloud, and then in the future we'll also have partner third-party VAs that we can insert at the branch as well.